Hello, thanks for talking to me. I'm Dr. Tovar. I'm a physics professor here at EOU, and I'm looking forward to talking to you about an exciting new calculus-based physics program that we're implementing here. So for a lot of years we had a physics major here at EOU and a physics minor, but because of budget cuts and the change in state funding, we had to cut the major and then later cut the minor. So budgets got pretty tight here at EOU. One of the casualties of that was a calculus-based physics sequence was cut. And the problem with that was that several of our majors in chemistry and biochemistry, exercise science, they need that for graduate school. And so the problem is they've been having to take that somewhere else or not come to EOU at all. So really looking forward to this exciting change in our program. I'll be teaching the new sequence. I'm the physicist on campus. So the question comes up is, what's the difference between algebra-based physics and calculus-based physics? And part of the answer is that calculus isn't introduced just because it's a more complicated type of math. It's introduced because it makes things easier to explain. We can focus on the physics more than the math by having the higher math. So I've got a couple examples that I'll show you on the board. All right, in writing the constant acceleration equations, which are a fundamental part of the coursework in both courses, we start with the acceleration in the x direction and the acceleration of gravity in the y direction. And we can, with calculus, we can quickly move from this equation to here. And the same thing from here to here to here. In the algebra-based, we have to make some arguments about how these equations are valid. So it takes a lot longer to make this sort of explanation. Also, once we have the constant accelerations equations, we can get range formulas, y max, and time of flight formulas. One of the special equations we can get is a range formula if we're throwing things from one height to a different height. And this is the range, how far it goes. A projectile will go with a different given angle. So the angles were embedded in these formulas here, which are here and here. So this thing is R changes with angle. So the question is, what's the optimum angle? And normally you think, well, it should be about 45 degrees. And it would be if the ground was flat. But if we're going from a different height elevations, then it's no longer 45 degrees. And so the question is, what is it? Well, with calculus, we can take the derivative of r with respect to theta, set it equal to 0, and solve for theta. And we get this formula. Okay? We get this formula by taking a derivative using calculus. Without calculus, basically, we can't get this formula. We can't get this formula at all. So calculus makes our life easier here, and it makes it possible to do things we couldn't otherwise do. So if you're interested in kind of deep learning about the physical world and you want to take some more physics, calculus-based physics is offered this coming fall. I look forward to seeing you.